Hello, and welcome back to another review video. In this video, we will be covering derived units and volume conversions. This is Unit 1, Syllabus 5E, and volume conversions. Now, to start, derived units. Derived units are a combination of one or more base units. Base units being seconds as a form of time, meters as a form of length, kilograms as a form of mass, Kelvin as temperature, moles as the amount of a substance, ampere as an electric current, and candela as a luminous intensity. A derived unit is a combination of one or more of these base units. You should have learned more about these base units in class, so I won't be going in depth into them in this video. Derived units that you should know of are area, as represented by meters squared, volume, as shown by the cubic meter, density, as shown as kilograms per cubic meter, force, as the Newton, pressure, as a Pascal, energy, as a joule, power, as a watt, voltage as a volt, frequency as hertz, and electric charge as coulomb. Now, there are three specific derived units that you should pay specific attention to. One of these is weight. Weight is not the same thing as mass. Mass is measured in kilograms. Weight is measured in newtons. Weight, by definition, is the measure of force of gravity between two objects. Because weight has to do with the force between two objects, that's why it's measured in newtons. Next, volume. Volume is the amount of three-dimensional space taken up by an object. What's important to note about volume is that liters, one of the most common things used to measure volume, is not the SI unit for volume. It is in fact meters cubed. So, when measuring volume, even if you measure in a graduated cylinder that uses milliliters, when using SI, be sure to convert those milliliters into meters cubed. Lastly, density. Density is the mass of substance per unit of volume. Now, density, you can use the equation D equals mv to calculate. That is, that the density of a substance is equal to its mass divided by its volume. Now, this equation can also be manipulated algebraically to get the mass of a substance or the volume of a substance. Next, volume conversions. Before converting from meters cubed to liters, there are important conversions that should be known. For example, 1 meter cubed equals 1,000 liters. Next, 1 decimeter cubed equals 1 liter. And 1 centimeter cubed equals 1 milliliter. And while not necessary in volume conversions, it's important to note that when in three-dimensional space, there is a 3 times difference between the base 10 system of the metric. That is that 1 meter cubed equals 1,000 decimeters equals 1 million centimeters. So as you can see, there is a 3x difference between each step in the metric system. Now, to get started with some examples, this example tasks us with finding how many meters cubed 10 liters is. So to do this, we can use some dimensional analysis. We start over here. We know that 10 liters cubed is equal to x meters cubed. And we also know that 1 meter cubed is equal to 1,000 liters. This allows us to cancel out the liters and leave us with just meters cubed. In doing this, and when plugging it into a calculator if needed, that gets us to 0.01 meters cubed. So now we know that 10 liters is equal to 0.01 meters cubed. This next example tasks us with finding how many kiloliters, 1,000 liters, is 5 meters cubed. So, once again, we are going to use dimensional analysis to solve this problem. We know that x kiloliters equals 5 meters cubed, and we then multiply it by 1 meter cubed, as we know, because it's 1,000 liters. This lets us cancel out the meters cubed. We also know that 1,000 liters equals 1 kiloliter. This lets us cancel out the liters as well as the 1,000. So this one, while you can plug it into your calculator, you should be able to do it mentally. This leaves us with 5 kiloliters, which makes sense considering that 1 meter cubed equals 1,000 liters, and 1,000 liters is a kiloliter. Now, these next two examples, feel free to do on your own and pause the video to work out on a separate sheet of paper. The first example tasks us with finding 1 decimeter and converting it into hectoliters. Feel free to pause the video now. Okay, to solve this problem, we are once again going to use dimensional analysis. So, we know we have 1 decimeter cubed. We then know that 1,000 milliliters, otherwise known as 1 liter, is equal to 1 decimeter cubed. This lets us cancel out the decimeters cubed. Next, we also know that 1 liter equals 1,000 milliliters. This lets us cancel out the 1,000 milliliters in both of these fractions. And lastly, we know that 1 hectoliter is equal to 100 liters. This lets us cancel out the liters and leaves us with 0.01 hectoliters once it is plugged into a calculator. So, thanks to dimensional analysis, we now know that 1 decimeter cubed is equal to 0.01 hectoliters. Feel free to pause this video and work on the next example, converting 18.3 gigaliters into x nanometers cubed. Okay, to solve this problem, we're going to use more dimensional analysis. We know we started with 18.3 gigaliters. We then multiply this by 1 times 10 to the 9th liters. That's 1 billion liters, because we know that's how many liters a gigaliter is. That allows us to cancel out the gigaliters. Next, we also know that 1 meter cubed is equal to 1,000 liters. This lets us cancel out the liters. Next, we also know that 1 meter cubed is equal to 1 times 10 to the 27th nanometers cubed. This lets us cancel out the meters cubed. Lastly, once we plug this all into the calculator, we get the result 1.83 times 10 to the 34th nanometers cubed. So, through dimensional analysis and volume conversion factors, we now know that 18.3 gigaliters is equal to x nanometers, is equal to 1.83 times 34, 1.83 times 10 to the 34 nanometers cubed. That's all for this video.